gamers, and welcome to another video. Today it's Advent of Code. It's that time of year again, and I really want to see your solutions, so leave those in the comment section down below. If you want to support the channel, there is a link in the description to different affiliates where you can get great deals on things, and there's also a donation link if you want to donate a coffee to me in order to improve the quality of the channel. Day 6, Guard Gallivant. The historians use their fancy device again, and this time they whisk you all away to the North Pole prototype suit manufacturing lab in the year 1518. It turns out that having a direct access to history is very convenient for a group of historians. You still have to be careful of time paradoxes, so it will be important to avoid anyone from the 1580s while the historians search for the chief. Unfortunately, there is a single guard patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. You start by making a map, your puzzle input of the situation, for example. The map shows the current position of the guard, which is an up arrow, and indicates the guard is currently facing up from the perspective of the map. Any obstructions, crates, desk, reactors, etc. are shown as brackets or as hash marks. Lab guards in 1518 follow a very strict patrol protocol, which involves repeatedly following these steps. If there is something directly in front of you, turn right 90 degrees, otherwise take a step forward. Following this above protocol, the guard moves several times until it reaches an obstacle, in this case a pile of failed suit prototypes. Because there is now an obstacle in front of the guard, she turns right before continuing straight in her facing direction. Reaching another obstacle, a spool of very heavy long polymers, she turns right again and continues downward. This process continues for a while, but the guard eventually leaves the map area after walking past a tank of a universal solvent. Predicting the guard's route, you can determine specific positions in the lab in the patrol path, including the guard's starting position. The positions visited by the guard before leaving the area is marked with an X. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the map area? So, looking at my solution here, we first off have the reader, where we read in all the data. So we have lines. I've also mapped up the different directions. We have north, east, south, west in the right order of a 90 degrees turn. And then we have a starting position of X and Y. 0, we have a direction of north, and then we have the height and the width of the actual grid, which is lines and the length of the line. And then I will create a map of integers. Then we start going through the actual lines, reading the lines in an XY. So I have a counter here for Y, a counter for X. I reach each line, I split them into characters. I check if the character is a dot, then I put map equals to 0, because then you don't have any obstruction. And if the character is an hash mark, there is an obstruction, so I put a 1 there. And then if it's the actual guard, there is no obstruction there, but we also want to save the X and Y coordinates for that position, and then we iterate over and add to our counters. Next up, I create a while loop to see, as long as I'm in the designated area, so if X is larger than 0, and y is larger or equal to 0. X is smaller than the width and y is smaller than the height. Then we are on the map. We will look at the current position, and let's see, we start at the current position and set a -1 there, which means that we have visited it. And then we will start our walk and check in the direction we want to walk and see if we can walk there. If we can't walk there, we will change the direction. We will check if the direction is less than west, which means that we are at the last point and we need to go north again. So if it's less than west, we will add 1. If it's west, then we will turn north. Just so we start over again and go a full circle. And then we take a step here. So we check which direction. If it's north, we will decrease the y coordinates. If it's south, we increase the y coordinates. If it's west, decrease the x coordinates. And if it's east, we increase the x coordinates. And then we will check the number of spaces which has a 1 in it. So places we have visited. And we will count those up and print them out. This checked direction we have down here is just going through the map here. So we have the map. We check that if we are outside of the map, so we have left the map, then we say that this is true. It's okay to go off the map. Otherwise, we will check if the north direction is where we want to go, and we check if the value is smaller than 1, so we don't have any obstruction there. And then we do south, same there, check the south position, smaller than 1, and so on. All of those could be true, or we will return false if none of the directions are chosen. That will probably never happen. So running through this, we got a result and we put it in, and that was the right answer. So let's continue here. Part 2. While the historians begin working around the guard's patrol route, you borrow their fancy device and step outside the lab for the safety of the supply closet, and you travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Returning after what seems like only a few seconds, the historians, they explain that the guard patrol area is simply too large for them to safely search the lab without getting caught. Unfortunately, they are pretty sure that adding a single obstruction won't cause a time paradox. They like to place a new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all the possible positions of such obstructions. The new obstruction can be placed at the guard's starting position. The guard is there right now and would notice. In the above example, there are only 6 different positions where a new obstructions could be cause the guard to get stuck in a loop. The diagrams of the 6 situations use O as a mark for a new obstruction, and a dash to show a position where the guard moves up and down, and or a pipe up and down, and dash to show the position where the guard moves left to right, and plus to show the position where the guard moves both up and down and left and right. Option 1, printing next to the guard's starting position. So we have that. Option 2, option 3, and so on. A bunch of them. And then lastly, we realize that there are 6 different options where the guard could go. You need now to check where the guards get stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? So my solution to this, if we look at the B day here, is first off, the same as I did before, reading all the lines here, creating the different directions. I store the original state here of X and Y and height and width, and then I have an original map that I write to. So I've changed this up here, so I write an original map and an original X. Then I have started a loop counter here, so number of loops. Then I will go through the different X and Y, so dy and dx, and I will copy a new copy of the map, so I have a totally new map that I can work with. And then I will check that the current position that I want to change is not an obstruction already, because then I will continue, a little speed improvement. And then I will check if the current position isn't the original position, because we were not allowed to put an obstruction where the guard stands. So then we will continue, skip that. Otherwise, if it's not an obstruction or where the guards stand, we put an obstruction there, and then we set X and Y to the original X and Y, and we start in the north direction. I got a result here of 1454, which is too high for my current case. And then I have this while loop, which goes through and see that I don't leave the space again. And for each place that I'm visiting, I increase the current position. And if I have been to this position that I'm currently at more than 100 times, then I will increase loops, because then I'm probably in a loop. I have tried to increase this value up to 1 million. So it would be very unreasonable that I get in something that isn't a loop that visit the same position more than 1 million times. Could be. Then I check if I can walk there, and the check dir here is a little bit different. I've actually increased the knowledge about where I'm trying to go and if I can do it. So if I'm trying to go in a direction where I'm not allowed to go, then I will return 2, because 2 means I left the map. And then in the case where I'm allowed to move there, I return 1, otherwise I return 0 for check dir. So that's the difference of this check dir. So if I can walk there, it's a 0. If I can't walk there, there is a 0. So then I will change the direction. And if it's a 2, we know that I've left the map, so I can break already. Then that's not a loop. And then I have the switching direction and going so. And then I count the loops and print it out. This is not the correct solution. But I have gone through the code, thought about it a bunch, and I think it's a reasonable solution. But something is wrong with it, and I can't figure it out. If you see what's the problem here, or if you have any suggestions, please leave those in the comment section down below. I would love to see your solutions there as well. Leave those in the comment section down below. I will probably not read them until I figure out what's wrong with my code, because I like to do it like that. I want to be clean in my thoughts, but please leave your own solutions if you want to. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that, and I really hope to see you in the next video.